When you look at a wedge, it really doesn't look like the other simple machines at first glance, but it is a simple machine. It follows all the rules of a simple machine. And so to introduce this idea, what I want to do is I want to remind you, I want to go back to the inclined plane example. So let's draw ourselves some ball or some weight that we want to push up an incline. And let's say, let me get my pen tool out. Let's say that this weight is 10 pounds. So 10 pounds going down. And let's say that this incline is 1 foot tall. And let's say it is 5 feet in length. So I have two questions for you. If we want to push this weight up this incline, first off, what is the mechanical advantage? And of course, the second question is, what would be this effort force? And to solve for our mechanical advantage, I'm going to use our IMA equation. Our IMA equals dE over dr. And we know our dE and our dr. If we look, our distance effort is how far our force effort would travel, which is 5 feet up this incline. And we'll divide that by our distance resistance, which is the height of the incline, which is only 1 foot. And if we look, we'll see that feet cancel out, so we're left with 5 over 1, which gives us an IMA of just 5. And then to solve for our effort force, let's go ahead and assume an ideal effort force so we can use our ideal effort force equation, which says drs are free, or dE over dr is equal to Fr over Fe. And we know most of these numbers, right? So we can just say dE over dr is still 5 feet over 1 foot. That hasn't changed. And we can set that equal to Fr over Fe. And we know our Fr is 10 pounds. And we don't know Fe. So we can just leave that as a variable. And then we can just cross multiply and divide. And what do we get? We get an effort force of, well, we look, feet cancel out, and we're left with 1 times 10 is 10, divided by 5 is just 2. And for our units, we're left with pounds. Now, so hopefully that was just a review. There's nothing new there. But now I want to change the problem slightly. Let's say we have the exact same weight to lift up. And so it's still 10 pounds going down. And we still want to lift it up 1 foot. But let's say it's just sitting there, and let's say this time when we draw our wedge, the wedge is going to be the thing that moves. So instead of moving the ball up the ramp, let's move the ramp underneath the ball to lift it up 1 foot. So the main difference is where we apply our effort force. We are moving this inclined plane with this effort force from here off to the side, pushing it underneath, and then we can go ahead and label this moving inclined plane. Let's give it a height of 1 foot, just like before, and we can give it a length of 5 feet like before. And I know the bottom length is not the exact same as the slope, but the difference is so small, we can actually just kind of ignore that little tiny difference and just assume that it's the same for now. But the question is, will this change how our system works? If the incline is moving underneath the ball, will that change the mechanical advantage of the system? And so we can still use our IMA equation. We can say IMA equals dE over dr, and we already know our dE and our dr. Our distance effort is how far our force effort travels, and it'll have traveled 5 feet. So we can say 5 feet divided by the height that our weight will go up is only 1 foot, and so we still get a mechanical advantage of 5. And therefore, the effort it would take to push this inclined plane underneath this weight would also be 2 pounds. Because if we said our AMA is equal to our IMA, assuming an ideal effort force, we could say the AMA is 5, and then we can set that equal to Fr over Fe. Well, we know the Fr is 10 pounds. And then we'll set that over Fe. Let's say we don't know it and we want to figure it out. Well, we can then say 5 over 1 to cross multiply and divide, and we say 10 times 1 divided by 5. We still get an effort force of 2 pounds. And so a wedge is a simple machine. It's just a moving inclined plane that we might use for different reasons. In fact, we can go ahead and define a wedge for ourselves real quick. Let's go ahead and write it out. A wedge is a moving inclined plane that is used to either lift, split, or tighten objects. And so hopefully that wasn't too confusing. All the wedges is just a moving inclined plane. And the only place it really gets confusing is when you're trying to figure out what is your DE and your DR and your FR and your FE. But we'll discuss how to figure out what those are in the next video.